Hey guys, so last video we talked about the rate of change, and we used an example of you're a YouTuber and you're getting likes or follows on a video that you posted, and you're trying to see how many more followers am I getting every second, and it changes over time, and so you're trying to see on average how many followers do I get per second. And that would be, and we would use the rate of change to find that. And we did, and we found that you get about 3 likes or follows every 2 seconds. So I'm going to introduce another, the same example, but we're going to look at it in a slightly different way. So I've mapped out a function here on the graphing calculator, and I actually have a function to represent it. And that function is 1/4 times x squared, or you could just call this x squared over 4. That's another way to say it. I like writing it like this because that 1/4 is your coefficient and x squared is your x term. So, but either way, it doesn't really matter. And so whatever value you plug into x will give you the output, which is y. So let's rename these things. So x equals our seconds after the video is posted. So it's seconds after the video is posted, and y, which is f of x, equals the number of likes received. And that value depends on how long it's been since your video is posted. If you look back at your video in 3 weeks, you'll probably have a lot more likes because time has passed, and given that you're not a terrible YouTuber, you probably will have some likes. So this function is like this, and I used such a weird coefficient to give you some numbers that we can work with, some nice numbers. Of course, this could be any function, and any formula could apply to it, but this is for ease in explanation. Now we're going to liken the average rate of change to how many likes you get per second on average. And this might be a really decent way to do it, a decent way to figure out how many likes are you getting, how popular are you getting over time. But the problem is your popularity isn't the same. So you might get really popular really fast. Your video might go viral. And if that happens, then the more time goes by, the more popular you're going to get. And so what that means graphically, if you're a visual person, that means the more time that has passed, the more popular you're getting, the more likes you're going to receive. And so you'll get more likes in less time. It'll take you less time to get more likes, in other words. So you have your graph here, and we can say the average rate will be like, we could take 2 points, say where 4 seconds after the video is posted and 2 seconds after the video is posted, and compare those. Or maybe we could go from 4 to 0. So right when the video was posted, you had 0 likes. And then at 4 seconds, you had 4 likes. And you had 4 seconds in between there. So, 4 divided by 4, that's 1. So you're getting 1 like every second. But you can tell from the graph here, that's not actually happening. And you'll see that pattern doesn't really hold true. You're not getting, if you wait 300 seconds, you're not going to get 300 likes. That's not really how it works, because your popularity isn't a constant thing. It's going to change depending on your content. So that's why we have this function here to let us know where our x values will be. And so what we're going to do is we're going to find an expression that's going to tell us at any instant in time how popular am I getting, how popular am I becoming. And so what we're going to do is we're going to look at how these two rates, the average rate of change and the rate of change in 1 instant over time is. Now, remember what I said about what a derivative is? A derivative is the rate of change of the function at an infinitesimally small area around a point. So if you're looking at the point y equals, or x equals 2, y equals 1, so 2 seconds, you have 1 like. If you were to zoom in really close, you can see that you're getting just about 1 like every unit of time, or one unit of like every 1 unit of time. And it's about the same. But you'll see as you zoom out here, and as you go to another part of the function, that pattern isn't the same. So you go over here, and it's not quite the same. You know, you're getting a different, your number is changing. And so, I'm sorry guys, it's really hard to see my screen because it's recorded. But basically, comparing the two, these 2 points. So you want to know at 2 seconds how popular how popular am I getting? And so you say, well, halfway between, or if we take that out, we can look at the interval between 4 and 0, and the change in x is 4. So the y1 is 0 and y2 is 4. x1 is 0 and x2 is 4, and y1 is 0 and y2 is 4. It's the same. And so you say the average rate of change is 4 minus 0 over 4 minus 0, which equals, come on, focus, which equals 4 over 4, which equals 1. So you're getting, or you could say 1 over 1, so you're getting 1 like per second. And that's not really true. And we'll see why this is a good estimate for, it's kind of a good estimate, but it's not a really good estimate. And that's the difference between this. And as you get that, as you look at like a point, you know, from 2 to 4 to 0, if you look at a smaller and smaller point around 2, you're going to get a better and better estimate of that slope. And that's the point of a derivative, and we went over this when we learned about derivatives. So let's look at the instantaneous rate of change. And we're not going to look at instantaneous rate of change over an interval because it's counterintuitive. An instantaneous rate of change happens at an instant, or around a very, very infinitesimally small value around an instant. And so I'm making this way too long, but let me simplify what I mean. What did we say our instantaneous rate of change was? Well, it's our derivative. So f prime of this function, which is x squared over 4, so our derivative is that. And so, you know, what is our derivative? And let's solve it. Well, the rules of derivatives, I'm going to write it back in this form up here. So we have f prime of 1/4 x squared is equal to f prime, or is equal to 1/4 times the derivative of x squared, which you'll remember, you bring the 2, focus, you damn thing, is you bring the 2 out, multiply it by whatever's over here, and then you multiply it by x to the 2 minus 1. So that becomes 1/4 times 2 times x to the 2 minus 1 is just x to the 1. So 2x. And you could write the 1, or you could not write the 1. We don't write it by convention because it's implied that there's only one x. And so, and that's, you can put that over top, 2 over 4 x, which simplifies to 1/2 x. Now this is our derivative. This isn't our change here. This is our derivative, and and that's telling us this is going to be at any instant in time, or x, at any x. This is how we find out what the slope, how much we're changing in that instant of time. And so if you say, like, well, in half a second, how popular am I getting? And so if you look at 1/2 times 1/2, that becomes 1/4, and you'd get 1/4 of a like. And that's, or no, you wouldn't even get 1/4. Or it's the slope is about 1/4. That's right. So half a second, it's going up about 45 degrees. And so that's the slope of your line. And so basically you're only getting at that point in time, at half a second, you're getting 1 like every 4 seconds. And that's not a lot. You think like, wow, I'm not very popular. But as you continue, as time goes on, well, let's evaluate 2. At the instant of 2, this is the value we were looking at earlier. We tried to estimate it by looking at the value between 4, 1 like per second. So at 2, you input 2 for x, and that becomes 1/2 times 2, which equals 2 over 2, which equals 1. And you can say that's 1 over 1, or 1 like per second. And that's great. And look at that. You see our average in this case. It doesn't always come out cleanly like this. In this case, our average and our instantaneous rate of changes were the same. But it doesn't always work. So let's say we were looking at 10 seconds. I really wish I could just like leave this thing and let it like stay. So after 10 seconds, well, in our original function, at 10 seconds is 10 squared times 1/4 is, well, 10 squared is 100 over 4, which is 25. So at 10 seconds, we will have gotten 25 likes. So let's see, it's right up here. 10 seconds equals 25 likes. You say, well, how popular am I getting? How many likes will I have in 11 seconds? And that's the kind of idea you got to be thinking of. You looking at from one, how many likes you have at 10 seconds, and you know how many likes you have at 2 seconds, but how much has that changed? And how is your popularity changing from one moment to the next? How much more popular are you getting? And that's the idea that I really hope that this sinks into your brain, is that this is what we're looking at. It's a rate of change. It's how is whatever we're looking at changing over time, or over, it could be over distance or over some variable. We're looking at how it changes. So 10 seconds is 25 likes. And you could say, well, what about from 2 seconds to 10 seconds? Well, 2 seconds, if you remember, equals 1 like. So you could say that, well, the average rate of change from 2 seconds to 10 seconds is our 25 likes, our y2, minus 1 like, over 10 seconds minus 2 seconds, our change in time, which equals 24 over 8. Wow, that's a really nice clean number. I picked a good function here. 24 over 8 is 3. So you're getting 3 likes every 1 second. Focus, you dang thing. Man, just a little fuzzy in more ways than one. All right. So 3 likes are, and you see that's very different from one like per second. Now you're getting 3 likes per second. That's like, whoa, my popularities, I'm getting much more popular. Well, so that's your average rate of change, but that doesn't tell you how much, it doesn't tell you, it tells you how much you changed over that big distance, but it doesn't tell you how much you changed over a very small distance. And so we want to know what the slope is. So you use the derivative at 10 to give you an instantaneous rate of change. So you're looking at an infinitesimally small value around x equals 10. If you look here on our graph, here's 10 right here. And we're looking at it. We're going to zoom in really, really, really close. You see that? We're looking at like 0.99 there. We're zooming in very close. And we're looking at, well, what's this slope right here? From this point to this point, or even zoom in even further, from this point to this point, or this point to this point. Because we're getting closer and closer to that, and that's our derivative. So it's easy to figure that out. You just plug 10 into your derivative function, which is 1/2 x. So 1/2 times 10 equals, well, 10 over 2, which equals 5. So you're getting 5 likes every second. And that is, you're getting 5 more likes every second. And so I hope that made this concept a little bit clearer. Obviously, go over the Meadows videos, because she goes over the examples on how to do this, but she doesn't really explain the concepts very. It shouldn't take a long time to explain the concepts, and I think that is seriously lacking. With all due respect to her, she's a great lecturer, but we need to know the concepts before we can look at examples. But hopefully now you can watch her videos and be like, okay, I know what she's talking about here. So anyway, I hope this helped you guys, and I'll see you later. Bye.